Okay, today we're just going to be solving some problems about permutation and combinations. Let's start with this one here. How many different committees of 5 can be selected from a club of 27 members? And then after we find that, we'll figure out how many of these committees will include this club president. So you notice when you're finding a committee that it doesn't matter, there's no order. It's just, hey, let's make a group of 5 people. A committee is just a group, which means we're going to be using combinations or NCR. So we can just do this quickly. 27 members, groups of 5, n equals 27, r equals 5. So 27 C5. So we bring up our calculator and make sure we know how to do this. Math, probability, NCR. 27 goes here, 5 goes here. We get 80,730. If we think about the definition or the full equation for NCR, we will see 27 choose 5 is 27 factorial over 5 factorial, 27 minus 5 factorial, which will give us, simplifying, 27, 26, 25, 24, 23 over 5 factorial. And we can also do this. This one is also in probability. Divided by 5. You can see why we use the choose notation as opposed to doing this. Divided by 22. Math. And we get the same number. So we're happy. Moving to the second part of the question. How many of these committees will include the club president? So this is basically taking one of the members, whoever this club president is. One is already in the group. So how many people are we left with? 26, C, and we're going to pick 4. And let's just do this right here. Not waste any more scrolling. And doing it the quick way. 26 C4, 14,950. Great, we did it. On to question 2. 2 identical chemistry books and 3 identical math books are put in a pile. How many distinguishable ways can they be stacked if there's no restrictions? So we have 2 chem, 2 C's, and 3 M's. So, remembering that this will be 5 total things, but then 2 and 3 repeats. So 5 factorial over 2 factorial 3 factorial will be the total number of ways. Just putting your repeats on the bottom, which will be 5 times 4 over 2, 20, 10 ways. Remember, simplifying this, and the factorial becomes 5 times 4 in the worst way possible. If the books and the subject are kept together, what we end up having is just 2 objects. Because the 2 C's have to be together, so it can either be C, C, M, 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 or M, 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 C, C. And so just 2, that's it. Moving on to the third question. We have the letters P, Q, R, S on, I guess these are like Scrabble blocks. How many permutations will there be? So first, no restrictions. That's just 5 objects in order. 5. Looking at B, if the row must end in PQ, we have blank, 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 PQ. So basically, you end up with 3 factorial because we have R, S, and T split up in these ways. Similarly, if we begin with S, blank, 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 P, we have the 3 letters into 3 spaces, so 3 factorial. 20, 60, 120. 3 factorial is just 6. And there you go, we did it. We solved 3 permutation and combination problems.